Today, I mainly want to share a project with you, an automated quantitative trading project. Because this is a private project, you won't be able to see it in my repository. Since I'm currently collaborating with a quantitative analyst, this project likely won't be open sourced. I'm just sharing it here. In this project, you can see I've provided a complete trading description and the project structure, and the technologies I'm using. Currently, it's built with Node.js. In the future, if feasible, I may use Go to implement high-frequency trading. I've divided it into several modules: the front end, the back end, and the trading module. This includes a rough table schema, API documentation, a project-wide quick start, and how to use it. This is an overall guide with very detailed explanations. At the very bottom, there's also an architecture diagram. I can show you that architecture diagram. This architecture is designed around connecting to Binance. Initially, I planned to use ClickHouse for historical data storage. Later, considering that was too heavy, I switched to PostgreSQL with Timescale DB. There are various modules: market, indicators, strategies, risk control, and orders. Then we can look at the code structure. It's divided into a Binance project and another project for futures trading. I also have a complete English version of the project description. It also explains the project structure, highlights, core systems, and parts of the tech stack in detail. Let's first focus on the Binance module. This submodule has a corresponding README with documentation specific to it. Next, we'll take a closer look at things with a UI. First, let's review the source code. From the source code, we'll focus on the trader, the trading module I mentioned, and that dashboard, which is primarily a UI module. This trader is what we mentioned in the architecture diagram. The entry point is index.js, where we initialize some core modules. We also initialize connections and set up dynamic class injection, which I implemented myself. It's a class called service registry. Then we initialize indicators, decide which symbols to monitor or subscribe to, and finally shut down the system gracefully. In the core module, we start by using the service registry. This class mainly handles service registration. We register all usable services in it. I also use the factory pattern. Our concrete core business classes all inherit from a base service. For example, the market data module that ingests data inherits from this base service. This lets us share common classes without having to new them every time. I also use the singleton pattern, and all these services are registered in the service registry. And we declare each class's dependencies. For example, the market data module depends on a message producer and data storage. To decouple modules, I use 0MQ as an in-memory message broker for inter-service messaging. The whole project isn't very complex. It also includes configuration data, for example, configured trading pairs and their timeframes. My data and the entire table creation logic. And as I just mentioned, I use timescale for some time series processing. There are also components for data storage, message production/consumption patterns, and my timescale manager, which handles CRUD for timescale DB. This script serves as an initialization step. There's also a testing module for overall integration tests and tests of historical indicators, and our date utils and logging modules. Here, I want to specifically talk about date utils. Why? Because the data we get from the Binance exchange is all in the UTC plus 0 time zone. Since I'm in New Zealand, our local time is UTC plus 13 relative to UTC plus 0. That is, we add 13 hours, sometimes 12. DST plus 13. Standard plus 12. Dynamic. Let's talk about the core. The entire process ties back to the architecture diagram we just looked at. As shown in the architecture diagram, our entire process maps back to that architecture. We drive the entire process with an event-driven model. After we subscribe to Binance data, it is pushed via WebSocket, order book, trades, clients, etc. Then, through the event-driven flow, 0MQ, ZMQ, emits events, which are passed to the indicators. We'll use the market data to indicators path as an example. Have a quick look. For market data, we first connect to our exchange and then obtain the data. After getting the data, we parse it and simultaneously publish an event to process it. Perform some time conversions, and then publish another event. After the event is published, something will capture it. For example, here we can capture it. Then I have a store that stores market data from the queue. At that point, it's captured. We store the data and publish the next event, because once data arrives, we need to compute indicators. As this is a project I'm collaborating on with an analyst, I won't go into strategy details. But the overall logic is event-driven. I register a message handler, and through it compute indicators like KDJ and MA. After the indicators are computed, the data is pushed to our strategy module, like the one here, and the strategy engine performs the logic, eventually generating orders. That's the whole trading system. After the trading system is in place, we also have a corresponding UI system. It's called the dashboard. The dashboard is divided into two parts. Let's look at the dashboard. It's divided into two parts. One is the front end. Inside the front end, there are sections such as the dashboard, K-line, candlestick, chart, order query, profit analysis, and a capital calculator. Then there's the back end, the server, which handles data exchange. Okay, next we can quickly run the project to see how it works. To run the project, there are two parts. First, run the back-end trading system to generate usable data. Then run the dashboard UI built with React and Node.js and use it to display the data. So we first run the command npm start. Press enter, and you can see detailed logs as the system starts, including initializing services, initializing the connection to the trading system, and setting some ready keys in Redis. Then initialize OK lines. At this point, we can see the program has started and is refreshing data in real time. This data is the live data from Binance, from the Binance exchange. We can cross-check it. You can see this is a Binance application, and it shows 8,689.36. The close price shown on my screen is 8,689.3736, which is effectively the same. So from this we can see we've connected in real time and are computing indicators in real time. After the integration is ready, how do we view our data? To make it easier for everyone to view it, I've developed a full stack system for this. The front end is developed with React. Its entry point is here. There are modules such as the dashboard, K-line chart, order query, profit analysis, and a capital calculator in the menu. So the backend is just a server for it. All of these command configurations, if you're familiar with Node.js, are set up in package.json. There are many commands defined in there. Based on these commands, let's run it and take a look. We'll start the backend system first using npm run server. After that, it's up and running, and you'll see detailed prompts. At the same time, start the client as well by running npm run client. Okay, at this point the front end is up as well, and it will tell us how to access the system. Next, we'll open our browser. After opening the browser, we first visit our URL. We can see it shows localhost here, so we'll use that to access it. At this point, we first enter the dashboard. We can see menu items like dashboard, candlestick chart, order query, profit analysis, and a capital calculator. On the dashboard page, there's a simple summary: profit, win rate, number of trades, and the profit/loss ratio. Analysts prioritize R. His strategy 50% wins, very high R. This ensures that a big winners more than pay off, while small losses are acceptable. So that explains the process behind our last 10 orders. The candlestick chart is a very important feature for our analysts. This chart clearly shows when we bought and when we sold, at which candlestick positions and at what times. It's very intuitive and clear. As for points A and B, those are specific considerations within this strategy. We don't need to delve into that. From a technical perspective, this feature is very useful. And we can zoom. You can zoom, right? This is just like using an application to view the candlestick chart. Apart from the candlestick chart, we have order query, which retrieves all our orders. In all orders, there's an actions column, mainly for viewing detailed information. It also includes what I just mentioned. Since the list only shows some key information, the details page contains all of it. Besides order query, we also have profit analysis. This profit analysis currently uses mock data. Why? Because it's still under development. Yes, our next goal is to support not only Bitcoin, but also Ethereum, BNB, then more, to enable comprehensive comparative analysis. so it won't be limited to a single trading pair. We can add others. The same applies to my trading system. I can dynamically configure other trading pairs. You also saw the configuration section in my index.js earlier. The last module is the capital calculator. In my view, the capital calculator is quite important because it lets us know how much capital to prepare and what we can buy. For example, if I want to buy 0.01 Bitcoin, so that might be just over 6,000 RMB. In NZD, it's exactly 1,486. And in our quote currency, USD, that's a bit over 800 US dollars. This provides a very intuitive view of roughly how much capital you'll spend to buy a given amount. It also factors in the exchange's fee rate, our transaction fees, and real-time exchange rate conversion. These exchange rate conversions come from real-time internet sources. These are the basic modules. The whole suite, including the trading system and the analytics system, meets our needs. That's the general picture. If you're interested in quantitative trading, we can continue the conversation. This is my LinkedIn. On my LinkedIn, you'll find a detailed introduction about me, including what I'm good at, as well as my portfolio and my main professional experience. And finally, the kinds of projects I've worked on. These include some AI projects, inventory management projects, enterprise projects, and data analysis projects. Parts of these projects are already in my open source repositories. I've open sourced them before. Another portion, being commercial and collaborative projects, hasn't been fully open sourced. My open source projects include some in machine learning, some AI assistance, and AI trading. The AI trading project is currently private. I'm planning to integrate AI modules in the future to handle several decision-making tasks. There are also some CH projects, Python projects, and so on. Finally, here are my contact details, since I'm based in New Zealand. So this is a New Zealand number, along with my LinkedIn and Gmail. If you're interested in quantitative trading, we can continue the discussion and share more. That basically covers it. That's all for today's introduction.